This graph will teach you about how to find velocity from a position versus time graph, like the one shown here. If you think about the equation we learned in class for velocity, it said that velocity was the change in position over the change in time. Position is on the y-axis in this graph and time is on the x-axis. Can you think of a quantity that we consider to be the change in y over the change in x? Hopefully you answered the slope. The most important thing to learn from this slide is that the slope of a position versus time graph gives the velocity over that time interval. So for example, the slope of our graph between 1 second and 2 seconds would give us the velocity of that object creating this graph between 1 and 2 seconds. A little bit more about position versus time graphs. I have 3 lines on a position versus time graph here in 3 different colors, and you're asked to describe the velocity of each of these lines. Go ahead and pause the video right now and either think about or jot down a word or two that may describe each of these lines. The blue line here, you can tell, is a linear line. That means it has a constant slope, which tells us our velocity is constant. The slope of this line is positive, and therefore whatever object created this blue line had a constant positive velocity, which means it was moving in a positive direction. Whereas the green line has a constant velocity again because it's a linear line, so a constant slope, but it was moving in a negative direction due to the negative slope. The red line's different. The red line shows that the object stayed at the same position over the entire interval, which means the velocity of the object is 0. These are 3 very simple lines, but what happens if the line is curved? Well, a curved line doesn't have a constant slope, which means it doesn't have a constant velocity. That would mean our object is either speeding up or slowing down. The last thing we're going to do here with position versus time graphs is we're going to take that graph that was on that first slide and we're going to use it to draw a velocity versus time graph. You'll notice I already have the axes set up here, but one thing that's missing are some labels for each of these little tick marks. Don't worry about labeling the velocity graph, or sorry, the y-axis yet, but we are going to go ahead and use those same time measurements on this x-axis. Now that our axis is labeled, our x-axis is labeled, we can go ahead and start drawing our graph. Looking at this position versus time graph, I noticed that there are 5 different sections, but 3 of those 5, the object stayed in the exact same position. That is indicated by a horizontal line on this graph. At those times when position is constant, the velocity is 0. And so those will be represented as a horizontal line on the velocity versus time graph as well. So go ahead and draw those in on your own velocity versus time graph. So there we go. We have these 3 sections here. Now we're just worried about the time interval between 1 and 2 seconds, as well as the time interval between 4 and 5 seconds. And we can see that both of those time intervals have a constant slope. And so we need to calculate that slope the same way you would calculate slope in a math class, doing rise over run. So for this first section here, the slope would be 2 minus 0. Start off with this point, it's at a height of 2, and this is at a point of 0, divided by 2 minus 1, which gives us a slope of 2. And of course we need units on that. The units are meters per second. So then we have one other portion, and that's our portion up here. For this portion, rise over run would give us 2 minus 0, start off here down to there, divided by 4 minus 5, which gives us a velocity of -2 meters per second squared. We can now take those velocities and put them on our velocity versus time graph. And now that we know what the velocities are, we can add axes labels here So go ahead and label your axes, and I will do the same. Now that my axes are labeled, I'm ready to finish the graph. So between 1 and 2 seconds, my velocity is 2. So I'll put a line there, and it's constant because the slope was constant. And between 4 and 5, my velocity was -2. So we'll put a line there as well. Now, we typically like continuous graphs, which means we like things to connect. That means that we'll have a graph that looks like this. Now, of course, my lines aren't perfect because my things are not all in the perfect space. What can I say? I'm human. So I'll move these around so that things actually look connected. There we go. So that is my velocity versus time graph that correlates with this position versus time graph. Again, the method you go through after you've labeled all your axes is that you look at the slope of each portion of this graph, and then because these slopes are constant, we get this nice kind of step graph in this velocity versus time graph. That's the end of velocity versus time graphs. In class tomorrow, you'll get a chance to experience what it's like to make your own velocity versus time graph using motion.